All right, good afternoon. We're going to talk now about the organizations of matter basic chemistry. Now, why do we do chemistry? Well, this is a post I found online, and I'd like you to take about 10 seconds, read it. Tell me if you do this experiment. All right. Well, this experiment was posted on 4chan, and it describes making crystals. And well, if you look at the directions, it involves mixing ammonia and bleach and then breathing heavily in a soda straw next to the container where you do that. That is a method to create chlorine gas, which will melt your lungs. And when this was posted online a few years ago, 17 people died. 12 of them small children, which is really sad. They were home alone and thought they would do something fun, and they ended up paying with their lives. But that's not what I wanted to focus on. 5 of them were adults who were doing this experiment with them. This is why you're taking chemistry in high school. We want you to be able to understand enough basic chemical techniques and formula to understand this will kill you, and to prevent you from being one of those 5 people who may have killed themselves and a brother and sister trying to do an experiment like this. You can buy all these ingredients, I believe, at middle school age and above. So, yeah. Now, the forerunner of chemistry is alchemy. Alchemy was obsessed with transforming lead into gold and involved astrology, magic, demon worship, everything possible to turn this worthless material like lead into something really expensive like gold. And that leads us to the founder, I believe, of modern chemistry is Robert Boyle. He is a 17th century alchemist and my favorite witch. Mr. Boyle basically bought as many grimoire magical books as he could, and he just started running every experiment he could out of them, throwing his family fortune into these experiments and documenting them down. In the process, he would mix blood in cauldrons with bat wing or eye of newt and would write down, oh, after boiling for 4 hours, I have glop at the bottom. And his observations, what changed, what didn't change, what happened, is the foundation of chemistry. We just started running these patterns of experiments and creating chemistry from them. Chemistry is a physical science about the composition, structure, property, and changes of matter. Chemistry focuses on turning one material into another, either by taking elements, turning them into compounds, compounds back into elements, or creating some variation thereof, and often creating useful products that we can use in the world around us. Chemistry allows us to make food that can feed millions. It converts things that wouldn't normally be able to be consumed into things we can consume. It creates drugs. It creates cheap and durable materials that make the clothing that you're wearing, the computer you're using, and everything around you. Now, the foundation of chemistry is matter. Matter is anything that has mass. Matter includes things you can hold in your hand. It also, if you move your hand back and forth, you can feel the air against you. That is also matter. If it has mass, it takes up space, it is matter. Now, mass is the amount of how much gravity affects something. It can be known as weight, but it can also affect things that have weight so small you can't measure, like the air around us. The air has weight. It just doesn't work on a traditional scale. However, that weight is pushing you into the shape you are. If I threw you into outer space, you would pop. That is the idea of matter, something that has that mass, and mass is that thing which creates the downward force that gravity grabs, which is weight. Now, all matter and everything is made up of atoms. These are the smallest bit of material you can have that can be individually unique. You can have different atoms of different elements that have different properties. If you try to break an atom apart, you start going into nuclear physics and mixing electrons and protons to make atoms. But at its foundation, everything is made up of atoms. Now, right here, I have charcoal briquettes for barbecuing. We have diamonds. And we have carbon nanotubes, which are used to make some very strong material these days. Now, all of these products are just the 6th element on the periodic table. Depending on how we lay them out, if we have them all swished together without any order, that's a charcoal briquette. If we have them in this delicate matrices, that's a diamond. If we have it in an even more delicate tubular structure made up of lots of little hexagons of carbon, that is a carbon tubule. All of these are the same element. It's just chemistry has allowed us to rearrange them in different ways. Now, atoms are what we break all matter into the smallest level. When you have all of the same kind of atom, you have an element. If you have two kinds of atoms mixed together, that creates a compound. Elements made up of all of the same atom, compounds, mixtures of different atoms. Now, we're going to see lots of atoms on the periodic table, and you need to be able to read this. When you have a substance, you have a letter. It's going to be either one capital letter or a capital and lowercase letter. We call that the symbol. And then there's going to be two numbers. Usually the small number's on the bottom, big number on top. But what's important is you'll have a big number and small numbers. The big number is known as the atomic mass. It's how much it weighs, which is a combination of protons and neutrons. And you have the atomic number, which is just the number of protons. To find out the amount of neutrons, just subtract the little one from the big one. That's it. Now, compounds are a mixture of more than one type of element. For example, water is a combination of two gases in our atmosphere, hydrogen gas and oxygen gas, specifically H2O, two hydrogens and one oxygen create one water molecule. And that's what it looks like. If you have any questions, here's our emails. Thank you very much for your attention today.